right, you guys, our very first videos for studying for our midterm, I'm going to go over the test review. My suggestion would be, because even though I go over these particular questions, since we get to use our notes and our review, what I would suggest, especially for like radical expressions, is keeping a list of, in your notes that you can use all exponential relationships or all exponential rules, because it might not be one of these 5, right? But I can get you guys started. So A, we have the square root of a squared plus b to the 5th. So this first one is the square root of a squared times b to the 5th. And I'm going to change that to the square root of, I'm going to keep a squared, but I'm going to change it to b squared, or how about b to the 4th times b to the 1st, okay? Because b to the 4th times b to the 1st is the same as b to the 5th, but now b to the 4th has a square root. A squared has a square root. The square root of a squared is a. The square root of b to the 4th is b squared. And then we just still have the square root of b to the 1st power, but we cannot simplify that anymore, so this is going to be the most simplified. Now, also, you could also write this, remember, to the 1/2 power is, so we have a, whoops, we could have a, b squared, and then b to the 1/2 power, which I guess would be the same as a times b to the 5/2, because 5/2 is 2.5, and when I add 2.5, or 2 plus 1/2, I get 2.5. The reason why I put all of these different answers on there is because if you're taking a multiple choice test, it could be any one of those answers that is the correct answer. So you need to know that you can rearrange it several different ways. Okay, the cubed root of 24, this should be, and you can use your calculator on this one because I think there's a perfect answer, or maybe not. The cubed root of 24, I'm going to change 24 to be 8 times 3. It's 24, right? And the reason I did that is because I know 8 is the same as 2 cubed, because 2 times 2 times 2 is 8. So now I can take this 8 out because the cubed root of 8 is 2. And that would be 2 cubed root 3. Okay? 3 does not have a cubed root, perfect cubed root. I guess you could rewrite this as 2 times 3 to the 1/3 power. The cubed root would be the same as the 1/3 power. Like I said, I'm not sure what the answers would be. So just remember, if you keep in your notes a list of rules, that might be the easiest way to help. And practice using them. Practice manipulating them with these practice problems, but maybe keep those rules of exponents there. You can look those up online. Okay, now we have the cubed root of, and I'm going to change x to the 5th to be x cubed times x squared, because that's going to be x to the 5th, times y cubed times y cubed, because that's going to be y to the 6th. And I changed it to be cubed so that I can take out the cubed root of x cubed is x. I can't do x squared, but I can do y and y, so I bring out 2 y's, right? But instead of y times y, I'm just going to do y squared. And then I still have the cubed root of x squared. You could potentially rewrite this as x y squared x to the 2/3 power, and then you could combine those x's by, it'd be x to the 1st, 1 and 2/3, which would be 3, 4, 5/3, so that would be x to the 5/3 y squared if they only wanted exponents and didn't want any radicals. Alright, so I'm going to, hopefully you can kind of see where I'm going to go with this. I'm going to change the inside to b. I'm going to keep x to the 5th because that'll cancel out. And I'm going to change y to be y to the 5th times y to the 1st power, which would be y to the 6th power. And then I can take out an x and I can take out a y because it's the 5th root. So I'm going to have xy times the 5th root of y. And then you can kind of see where I'm going to go with this. That's going to be xy times y to the 1/5, which could be x times y. If this is really 1 plus 1/5 is 1 1/5, which is the same as 6/5. So y to the 6 over 5. And all of those are equivalent expressions. All right, simplify each of the following expressions. If you were taking a power to a power, remember that you multiply those exponents, but then remember you have to do the number separately also. This is 25 to the 1st power. So what do I get here? I get 25 to the negative 1/2 power. And I have x to the negative, it would be 4 over 2, which is just the same as 2, the negative 2 power. And remember, if a power is negative, it just means that it's on the denominator. So each of these, I'm going to have this be 1, I'm probably doing more steps than you actually need to do. 1 over 25 to the positive 1/2 power times x to the positive 2nd power. And I'm just going to do one more thing because I know that 25 to the 1/2 power, if you ever have just numbers, you can get a number answer. 1/2 power is the same as the square root. The square root of 25 is just 5. Okay, so we have 1 over 5x squared. I guess technically positive and negative 5x squared. All right, next problem, power to a power. I'm going to multiply my exponents first. So I'm going to have x cubed y to the negative 5th power over x to the negative 2/3 power y to the 1st power, because 3 times 1/3 is just 1. Now I'm going to flip anything that's a negative exponent. I'm going to flip it and put it on the opposite side of the fraction. So my numerator is going to be x cubed y to the negative, or to the positive 2/3 power over y to the positive 5th power times y to the 1st power, which is going to be y to the 6th power. Okay, and is there any way to simplify it more? I don't think so. I mean, I have a y on the numerator and denominator, but it's not quite the same base because the y on the numerator is to the 2/3 power. So we're just going to keep it like this. Oh, I see what I did wrong. Do you guys see this? This is not a y, it's an x. This is what happens when I'm trying to do this when my head is really hurting. That's an x. Why did you guys let me do that? X to the 2/3, so I can combine those two x's. That's going to be x to the 3 plus 2/3, which is 3 2/3, as a mixed number over, give me 1 second. All right, we have some things happening at school here, but I'm back. So this is the same as, if I turn this mixed fraction into an improper fraction, x to the 11/3 over y to the 6th. All right, next question, x cubed plus, and then this becomes just x, right? Because it's to the power of 1, because the power to a power, I multiply that. 2 times 1/2 is 1. And I cannot add those because they are not like terms, but I could factor out 1x and have x squared plus 1. Okay, I could do that. Let's see. Do I have time to keep going? Yeah, I have a little bit of time to keep going. Okay, wait. Rewrite each of the following radical expressions using fractional exponents instead of radicals. Okay, so the root, this is going to be on the denominator, and this is going to be on the numerator. So this is just equal to 5 to the 2/3 power. Okay, and then this one, it's just going to be the same, because if you want me to expand it out, you're going to have 2 to the 1/4 power. That's what the 4th root of 2 is, to the 5th power, and now we have a power to a power, and we can multiply, so it's just going to be 2 to the 5/4 power. Okay, square root of 7 cubed is going to be 7 to the 3/2, because it's the square root. This is going to be, well, let's do this. On the inside of my parentheses, the square root of 7 is going to be 7 to the 1/2 cubed is going to be equal to 7 to the 3/2 when I multiply. And that looks like it's a fraction, but I'm trying to, it's an exponent, right? It's just hard for me to write this nicely. Mr. Writer had much better handwriting than I did. And this is just 7 to the 1/2 power. So make a note of that so you can use that on your test. I think I can keep going. Oh, whoops. Then this is going to be 3 to the 1/3 power. Okay. That was quick and easy. Rewrite each expression in simple radical form. Okay, so this is really the square root of 9 times 2, and I picked 9. 9 times 2 is 18 because 9 has a square root. It's 3, so this is really 3√2. And then I'm going to do the same here. 9 times 3 is 27. So this is really going to be 3√3. And then this one, let's see, what can go into 32 that has a square root? 4 can, 8 can, but 8 doesn't have a square root. Oh, 16 times 2 is 32, and 16 has a square root. So let's do 16 times 2 times b squared times b, right? Because then I can take out, 16 has a square root, b squared has a square root. So it's going to be 4b square root 2b. All right, that's all I'm going to do on this video.